to lesson 104. We're going to use your notes and what you know about circles to help us solve some real world problems. Here we have part of a basketball court. We have the sort of rectangular part here. And we have that half of a circle here, which we just learned is called a semicircle. We want to find the perimeter and the area of this half court, this half basketball court. All right, let's start with perimeter. Perimeter is the distance around. I don't immediately have a formula for something that has a curve and some straight lines. However, if I think of this as two pieces, as being a semicircle and a rectangle, I do have formulas for circumference of a semicircle and perimeter of a rectangle. Let's fill in what I already know. If this is a rectangle and the top is 4, that means the bottom is also 4. All of our work will be in meters today. This one's a little more tricky. Take a second. If this is the radius, that means that any other line from the center to the outside circle would also be 5. So if I drew one here, it would be 5. Or this dotted line here from the center to the edge of the circle will also be 5. All radiuses are the same distance because the distance from the center to the outside is the same the whole way around. I have another radius. The distance from the center here to the bottom of the circle will also be the same. They're all a radius. That helps me because now I know how long this line is. If this part is 5 and this part is 5, then the whole distance is 10. If this side of my rectangle is 10, then this side of my rectangle is also 10. All right, I'm partway there. I now know my distance around this. What about my circumference around my semicircle? Well, I know that circumference of a whole circle is 2r pi. I just learned from my notes that circumference of half a circle is 2r pi divided by 2, divided by the fractional part. Let's do that math. The circumference, I'll just put it as c, equals 2 times r times pi divided by 2. We're dividing it into half because it's only half a circle. Well, 2 times r. My radius is 5. Do not be confused and do 2 tens. It's 2 times the radius, which is 5. 2 times 5 times pi divided by 2. I see immediately that my 2's cancel out, leaving me with 5 times pi. That would be the circumference of this part of my figure. Now I can add on my other circumference pieces. Or I'm sorry, my other perimeter pieces. I have 4 meters here, plus 4. I have 10 meters here, plus 10. And I have another 4 meters there, and I'm back to the beginning. Well, I cannot combine my pi with my other numbers, but I can combine these terms. 5 pi plus, so this is my perimeter, is 5 times pi plus 4 plus 10 plus 4. 4 plus 10 plus 4 is 18. I could leave it as 5 pi plus 18, or I could look back at my directions. If they told me to use pi as 3.14, I could multiply times 3.14 and then add. If they told me to use pi as 22 sevenths, I could take 5 times 22 sevenths and then add on the 18. Either way, this number of meters would be my perimeter. That's not so bad, right? And now that we have our measures, we can find our area. I know how to find area of the rectangle. Area of the rectangle is length times width, which in this case is 4 times 10. is 40 meters. Area of my semicircle, I'll draw half a circle here, is going to be the area of a full circle, pi r squared, divided in half, divided by 2. So my area of my semicircle is going to be pi times r squared. My radius is 5, that's my r, divided by 2, which is pi. 5 squared is 25, divided by 2. There's not an easy way to reduce it from this point. You would probably leave it this way. If it asks you to use pi as 3.14 or as 22/7, you could then complete the rest of your math. Either way, by finding the fraction of the circle, you were able to solve. Similarly, we can use that same process to help us with this one. Here I have a sector. Looks like a piece of pie. Piece of pie. I know a circle, a whole circle, if I go the whole way around the circle, is 360 degrees. This tells me that the distance around the circle from one side to the other side is 300 degrees. That means that this remaining distance must be, well, 360 minus the 300 here. This must be 60 degrees, this little slice. And then I have a radius. I know that from the center to the outside is 6 meters. Area of a whole circle is pi r squared. And I don't want the area of a whole circle. I want it of this part of the circle. When I wanted half of a circle, I took half of my area. What fraction is this? I've got a 60 degrees out of the whole 360. When I reduce that, that's 1/6 of my circle. If I took 1/6 of my area, it would give me the area of this sector. So area for this particular sector is going to be 1/6 times pi r squared. Another way to think of that is to take your pi r squared and divide by 6. In this case, our r is 6 meters. Pi times 6 squared divided by 6. I have two choices here. I can square 6 and then divide 6 out. Or I know that 6 squared is 6 times 6. I can cancel 6 out of the top and the bottom. That leaves me with 6 times pi. And my answer would be in meters. We're going to be solving some other problems today. But as you look for area and circumference of parts of a circle, just look for the fractional piece of the circle that you want. Then multiply that fraction times the formula for either area or circumference, whichever it is that you're looking for.